A very warm and energetic morning to our Management Secretary, Sri Lalit Kumar OJ, Principal in Charge, Dr. N. Sujataman, our Organizing Convener, Dr. G.P. Bhavani, and all the aspiring chemists and researchers joined us with us today. It is a pleasure to welcome you all back to the third day of our international seminar on emerging technologies in chemistry. After exploring the digital tools of bioinformatics yesterday, we today turn our attention to the physical frontiers of our planet, sustainable energy, and the environment. It is a great honor to introduce a man who doesn't just work with renewable energy, but as he says, live and move along with the wind. Dr. N. Karunamooorthy. Dr. N. Karunamooorthy is a founder and managing director of WINDPLUS Private Limited and serves as the director of KP Groups. With a career spanning over 30 years, he is a titan in the onshore wind power technology sector. His academic background is truly multidisciplinary, holding a doctorate in wind energy from the USA, an MTech in electric and electronics, and most recently, a professional certification in entrepreneurship from IIM Kozhikode. His influence in the energy sector is global. He serves as a vice president for the World Wind Energy Association and is a member of ARENA Coalition for Action Towards 100% Renewable System. From managing massive EPC power projects to authoring the insightful book Mind of Wind, Dr. Karunamooorthy has been at the forefront of India's green energy revolution. Beyond his technical mastery in project management and carbon advisory, he is a scholar of leadership science and an ardent philanthropist. He has represented India on international stages from Australia to the Philippines, discussing the safety and sustainability of renewable energy systems. Sir, as a chemist, we often look at molecules and reactions, but today we are eager to hear from you about the big picture, how these materials and technologies scale up into the industries that will power our sustainable future. Your journey from an engineer to a global entrepreneur is an inspiration to every student here. We are delighted to have you with us, sir. The floor is all yours.
Yeah. So thank you very much. I really honored to be part of this international seminar that broadly talks about emerging technologies in chemistry. Right. I am sharing my screen. So I am from the wind industry. You have given a nice introduction. So almost 3 decades plus. Right. I am sharing my screen to. Yeah. Is my screen visible?
Yes, sir.
Correct. So today I am going to, in this international seminar program, I am going to cover up wind energy basics and its importance, because I would like to, know the students know about this wind energy, why wind energy and its importance. What are the importance of the wind energy? I can probably say that, some introduction like in our country, like now the government of India's energy mix in the sense, there is a renewable energy and non-renewable energy or fossil fuel used by fossil fuel, right? In that, renewable energy contributes even today only 31%, and the remaining 69% domination by thermal, I can say. And having this 69% domination, we have a 3 major disadvantages. One is relying on the other countries' raw material. I mean, for the thermal energy, our country is importing the coal from Australia. Okay. And secondly, there is a pollution. When we use more thermal power, there is a pollution. And third, the energy is not viable at all. Okay. Because we import something and then we produce the electricity for our needs here. That is 69%. We are relying on the other countries' raw material. Okay, this is a big threat it's a big energy threat, I can say. So we are into, if suppose now this India, Pakistan, and now Iran, Israel war was going on. So some misunderstanding happened between India and Australia sometime. Then we will be in a big threat. I mean, if they stop supplying the coal to India for any reason, then almost 14 to 15 hours our country will be in dark. That is the situation we are living in at this moment. So as ma'am rightly pointed out, so we have to have our electricity or energy demand to meet our energy demand in a sustainable way. So that way our country is blessed with 8 states, RE rich states. I can say Tamilnadu, Karnataka, Andhra, and then Maharashtra, Rajasthan, MP, Gujarat. So these are the 8 states our country is blessed with having more potential, RE potential, renewable energy potential. So let me take you to few slides. Right, the sources of energy. There are renewable energy and non-renewable energy. You can understand from these pictures, what are all the energies are renewable energy and what are all the energies are from non-renewable sources. Okay, renewable energy majorly wind and then hydro, solar, geothermal and biomass. Non-renewable energy, oil, coal, gas and nuclear. Okay, so here I would like to mention something like, the carbon, like from the renewable energy, 1 unit production, almost only 6 grams of carbon is emitting. Whereas all the non-renewable energy, if you use the gas, 450 grams for generating 1 unit of electricity. There is a carbon emission. And then by using the coal, for generating the electricity, there is a 900 grams carbon emission is happening. That means that is what, if we have this energy mix, this renewable energy as 31% and this is 69%, then we are in a big threat of one is energy security and also the pollution is more from the non-renewable energy sources. Yes, so why wind energy is important? Clean and renewable source. Okay, it is a very clean energy, green energy. As I mentioned, only 6 grams of carbon for generating 1 unit of electricity from the renewable energy. So without carbon emissions, supports climate goals and it is there are 17 sustainable development goals set by our government of India and across the globe, out of which SDG 7, that is Sustainable Development Goal number 7, which specify affordable and clean energy. Right, and SDG 13, that is Sustainable Development Goal 13, is climate action. So having this renewable energy as importance, we are fulfilling this SDG 7 and SDG 13. Then energy security, I explained you. So what threat we are living in, having the other countries' raw materials as a 69% of source for our energy demand. And then scalable and versatile. Economic, because the renewable energy cost is less than 3 rupees per unit, whereas when we are importing and generating electricity from the non-renewable sources, this energy, electricity cost is going more than 8 or 9 rupees per unit. That is the only reason so far our none of the discom, that is distribution companies in India, are in the positive cash flow. Even Tamil Nadu electricity board is also negative cash flow, because they cannot sell the electricity 8 rupees at 9 rupees to us, because one is people will be very very much upset, but and secondly, for a fund, we will not vote for the government, so that also will be the things. So they cannot be in a positive until otherwise we are not generating our electricity, our energy demand in a sustainable way. For that, this wind energy is contributing a lot from the RE sources. Yeah, this is the installed capacity in India as of last year, 31st 12/2025. So 2 months ago, this is the situation. This is the condition at our energy mix. All India installed capacity is 513 gigawatt. Okay, out of which RE is contributing 258 gigawatt. And gas, you can see the contribution: coal, gas, diesel, nuclear, small hydro, wind, biomass, solar, large hydro. This is the energy mix of our country, in which renewable is almost the installed capacity 50.22, and others is coals, non-renewable is 44.44. It is the installed capacity. It is not the electricity production. It is the installed capacity. Yes. Now the source wise breakup for RE generation for the month of December 25. What is the breakup in the particular month? The source wise breakup of RE generation for month of December 25, it is this much million units, 32,098. Okay, this is a million units for 1 month we are consuming our country, out of which wind is contributing how much percentage, small hydro, large, this pictorial representation, what source is contributing how much percentages in a month in our government of India's energy mix. Then That is a basic idea. Okay, so now the how does windmill generates the wind energy? You should know how it generates. You are all a chemistry students, but you can understand this is, there is a rotor blades which is converting from kinetic to mechanical, then mechanical to electrical. Okay, these are the three major components or three major drives, we can say. Drive train, we call it as in electrical, I mean in the wind energy language, drive train. There is a rotor and there is a gearbox and there is a generator. This is the three major components. So from kinetic energy into mechanical energy into electrical energy, this is what happening when the windmill operates. Then once the electricity generated from kinetic to mechanical to electricity generated, how the transmission and distributions are happening. This is the schematic diagram. Okay, here you can see there is a wind farm, then it is generating electricity which is being transmitted to via this transmission line to the nearest substation, and then from there is a transmission towers and we are using it for the distribution. So even though you are a chemistry students, but you can understand what's happening here is generation, transmission and distribution. Generation from the wind farm, and that energy is getting transmitted through transmission tower lines, and then the same energy is distributed for industrial purpose or the domestic purpose. So generation, transmission, distribution. Then in this industry, there are three key major stakeholders of RE sector. And I can say that, even though you are the chemistry students, you still have the job opportunities or doing the business opportunities also here. These are the three key major stakeholders. One is IPP. IPP in the sense independent power producers who has only money. They don't have neither technology nor the skill. And second major stakeholder is the OEM, who is having the technology, original equipment manufacturer, who are having only technology. And the third major key stakeholder is the developer, who facilitates. He is having money, they are having the technology. But on field, who will do the work? That is, buying the land, suitable land where the potentials are there, and potential in the sense where the wind and grid both are there. Okay, this is the land, wind, grid. That means this is the three dimensions of wind energy, I can say. All are four letters word, end with D. So 3D. Land anga irukanum, and then that land should have the wind. Every land you cannot put the wind turbines. Wherever the free land is available, you cannot. But there should be the potential also. Wind potential also has to be there. Then how we discover whether these wind potentials are there or not? There are certain methodology. We installed wind mast and we use a lot of satellite data, global data we have acquired from through the satellite data, meteorological mast, various sources to identify the to discover which are the land having the good wind potential. And then the grid is wind power cannot be stored. Okay, the immediately the generation, as I explained in the previous slide, there has to be generation, there has to be there has to be transmission and then distribution. We cannot store it. But now the recent days, the storage facility, storage technology has come up just now emerging, and this conference also talking about the emerging technologies. Now this battery energy storage system, that is also one of the emerging technology. Now we can store the wind power also. So the emerging technology, the first pilot projects are happening in many regions of our country. So these are the three dimensions of wind energy. There has to be a land, there has to be wind, there has to be a grid also. So these are the three key major stakeholders. You should understand. One is having money, one is having the technology. But at the end of the day, we cannot put the project. But there has to be a developer who can facilitate for OEM and IP. So he facilitated with these three. That is land, wind, grid. Yeah, this I have explained. All these three are important. Okay, only wind it is not possible, but there has to be enough land also. For putting one wind turbine, we need minimum of 7 acres of land. I mean, it is now this current prevailing models. I can say now the prevailing models are almost 4 megawatt each turbine. 30 years ago, but the technologies, wind technology is a 30 years old technology. So, I mean, I started my career first in wind 1995 when the wind technology started. Now it is a 30 years old technology. Before 30 years, we were having only small wind turbines starting from 200 kilowatt. Now, one single wind turbine is 4 megawatt. That means almost 20 wind turbines together. Now, one wind turbine, I can say. 2 2s are 4. Yeah. So 20 small wind turbines, which was there before 30 years. Now it is a single wind turbine, 20 wind turbines together. That must be, emerged technology has come up, right? So that is, land has to be there. That is what I mentioned. It is a 7 acres we need per wind turbine. But you can, think that, okay, 7 acres means a lot of agriculture land will be used, all those things. Yes, but agriculture land will be used by converting non-agriculture only for the minimum quantity. That is, only to have this tower and other things. But why we need 7 acres? The remaining 5 to 6 acres to, harness the wind by the rotor swept area. The blade length, it is almost 140 meter each blade. So then the rotor dia will be almost double the things, right? So that to cover this rotor diameter, we should have a more wind. But the farmers can utilize the land below more than, apart from that 1 acre in which the tower is installed. That means still they can use it for agriculture purpose. So land, wind, grid. These are the 3 key factors for wind energy. 3 dimensions of wind energy. Yeah, these are the 6 stages. WINDPLUS. Before we start up the company, any startup, you should have the business plans. You should have the methodology. You should have the business models, which services you are offering. So we are offering these 6 stages. According to my 3 decades of experience, there are 6 stages involved in developing, constructing, and delivering the projects. Stage 1, what we do, discover the potential. எங்கெல்லாம் wind இருக்கு, எங்கெல்லாம் substations இருக்கு, okay, where we have a good land also. ஒரு windmill க்கு வந்து I said 6 to 7 acres. Then if you are 100 windmills, then we should have a 700 acres. So this much wind potential, this much vast land parcels where it is. That and all we are doing it in the discovery stage, we can say. Land, wind, grid, discovering that one. And then acquiring the permits. For doing any projects, we should have a proper permits. As I mentioned in my starting this thing, there are 8 states. Every state is having different process, and permits need to be obtained to put up the projects. For example, Tamilnadu is having different procedures. Andhra is having different procedure. We need to follow that procedures and get the permits before we put up the wind turbine. That is what happening in the stage 1. That is discovering the potential. Second is acquiring the permits. Stage 2, once this potential is discovered, then we will start the land acquisition, because taking the ownership of the land. Nowadays we are taking for lease. Once we complete this 30 years of life cycle for the wind turbine, we are handing over the land back to the farmers. So land acquisition on lease basis, we are doing it. The stage 3, it is a electrical work. Stage 4 is a complete civil work. Stage 5 is the installation of the wind turbine, and stage 6, post installation, it is a 25 years is the O&M life. So these are the 6 stages involved in developing, constructing, and delivering the projects. Once the project is commissioned, the O&M life is for 25 years. So the project, once we start concept to commissioning, it is a 2 years time. After that, 25 years. So once anyone enter into this industry, minimum 25 years job guarantee is there. So this is the combination of all. as I mentioned, it is not only core people can join in wind energy or solar energy. Of course, the electrical, mechanical, civil, electronics people can join anytime, and others also can join. That is what I'm saying. It's a combination of all. For example, chemistry students. Yes, now I said now the battery storage system, that is BESS, battery energy storage system. This is the newly emerged technologies to store the electricity generated by wind energy. So in the storage BESS segment, you people can contribute. You people can join in wind energy because batteries are made up of with a lot of chemicals and other cells, so in which you can contribute your knowledge in it. So it is a combination of all. அதாவது டெக்னிக்கல் படிச்சா மட்டும்தான் we can join in wind energy. No, even non-technical, even the commerce people, BA, BCom, anyone can join. Everybody is having the openings here. And also this RE is contributing, I said 31% and 69% thermal, and we want to increase from 31% to 50% by 2030. That is another 4 years time. We want to keep this RE contribution by 50%, and we want to become our country want to become the net zero in the sense 100% energy demand meet from the renewable energy sources in a sustainable way. That will happen as per the survey by 2070. That means we have another 44 years. Yes, now 2026 to 2070 means another 44 years of bright future is there. There is a visibility that another 44 years this industry is going to boom up like anything. Why now our country or the PMO office is focusing to generate electricity in a sustainable way? Because our country has the more potential. Okay, wind, solar hours, the solar radiation hours per year, it is almost in a year we are getting 1500 hours in a year. Okay, so per day it is a 24 hours. 24 into 365 will be a somewhere 8760 hours, out of which 1500 hours are suitable for generating solar energy. And wind is almost all the 12 months we have a wind. Sometimes low wind, high wind, that and all that, but all the 12 months across these 8 states there is a wind potential also available. So now we have come up with the technology how we can combine both, that is wind plus solar. That is called hybrid system. And as a third vertical, wind plus solar plus BESS as a third one. Now the fourth vertical also has been discovered, which is a green hydrogen. Again, you people, chemistry people, can focus on green hydrogen. Okay, there are 4 verticals in renewable energy. Earlier only wind is the matured 30 years old technology. Solar is almost from 2010, 15 years old technologies. Now followed by wind and solar, BESS, that is battery energy storage system, and the fourth is the green hydrogen. So third and fourth vertical directly related to you. Having these 4 segments, we want to meet the net zero target set by our government of India, that is 2070. That is another 44 years of visibility is there for this industry. So now working of the wind turbine, I think, yes, yeah. You can see small video. Students who are present over here, some of few of you might have seen these wind turbines because it is there in the area of Tirunelveli and Nagarkoil, Aralvaimoli, Theni, Udumalpet in Tamil Nadu. But nobody would have seen on the top how it is, there, how it is placed. As I mentioned in my first slide, the drivetrain, that is a rotor, gearbox, and this green color, this is the generator. That means kinetic energy into mechanical energy into electric energy. This is what happening. You can see this is what rotor. Okay, if it rotates, which is coupled with the main shaft, this blue color, this big one is the gearbox, which is connected to gearbox, and then gearbox outcoming shaft is connected with the generator. If this rotor rotates, gearbox rotates. If gearbox rotates, the generator rotates. This is what the alignment is. You can see this, gearbox output shaft is connected with the generator. So this is all three are coupled: rotor, gearbox, and generator. So kinetic energy into mechanical energy into electricity. Here only the electricity produces. So once the electricity produces, I will not go into more depth of electrical. So this will be sent into the grid. Transmission will happen, and then from the transmission, distribution will happen. See, this entire unit can rotate 360 degree. In the direction and the wind vandalo, it will not, it will harness that wind to generate the electricity. 360 degree it can rotate. There are sensors. Now, there are artificial intelligence and other things. There are sensors inbuilt. Automatically, it will rotate. It will face the wind direction. From which direction the wind is coming, automatically it will rotate. This function we call it technically as a yawing, Y-A-W-I-N-G, yawing. Now you can see how the internal arrangements in the gearbox. Yeah, sorry. Not the video. Anyway, fine. Some mistake is there. Yeah, this one I want to see. Yeah, this mechanism is called pitch. So whenever the high wind comes, low wind comes, it will automatically rotates, pitch the blades. For that, it is useful. So there is a rotor, gearbox, and generator. Kinetic energy into mechanical energy into electrical energy, and then there is a yawing system, that is a 360 degree. It can rotate whichever the direction the wind comes. The entire unit will rotate and face the wind direction, because we needs more wind to apply on the rotor so that the rotor can rotate. And third is the pitch system, because if it is not adjusting, rotating based on the wind density and wind speed, sometimes the constant wind force, sometimes the high wind comes, the constant wind force apply on the blades, sometimes the blade may also break. For that only we are having this pitch system on the blades. Yes. So yes, I think you people, the students should have understood how this is working, what is the importance of the wind energy, what is the energy mix of our country at this moment. That is 30-70 you can keep, though it is a 31-69, but 30-70 you can keep in mind. And we have also covered about this one, like what is the government of India's net zero target, that is 2070 is the net zero target. So that our government is working towards day night, how we can promote this renewable energy in 4 vertical I have covered, that is wind solar hybrid. Then to store this energy, now come up with the battery energy storage system. And then 4th is the green hydrogen, that also I had mentioned. So there are four verticals. So it is not only for the core technical people, this industry, it is suitable for you students also. And I think this is part of my introduction, which ma'am has already covered. So I'm part of this Indian Wind Power Association as a treasurer, and the World Wind Energy Association. That is, I represent India to the world completely about, passion with wind. So, and Arena, yes, International Renewable Energy Agency. I'm also author of Mind of Wind book. So now we have some time for question and answer, so that I want to finish my presentation in 30 minutes. If students, ma'am, if it is allowed, then we can go for the any questions or something.
Second, sir.
Hello.
Yes, sir. Yes, sir.
Yeah.
Sir,
So
I'll post. Sir, I'll post the questions on the chat. So
okay, fine.
yes, sir. So first of all, it was very inspiring session, sir. That expertly linked the principles of sustainable energy with real world challenges and a large scaling up engineering and entrepreneurship. That's awesome. So we'll move on to the question session from the students. The first question here, it's mainly on the entrepreneurship. What is the most common blind spot the scientists have when they become entrepreneurs?
Scientists become an entrepreneur.
Yeah, because we are all chemistry background students.
Okay. So according to me, that is a 2C. That is courage and confidence. That only that traits we need. That's it for entrepreneurship. And money and other things are secondary, but it is not important also. For me, if you take this, WindPlus was started only in 2021 during the Corona period. Okay. Before I was working as a vice president, and I was earning more than 1 crore in per annum as a salary and all, but I still quit that and started this WindPlus. But now today, within 4 years of time, we have grown like anything. Like now it's 100 crores turnover company, and there are almost 103 people full time engagement. All these things in 4 years we have built, and the investment is not very major. It is only somewhat 50 lakhs. So I'm not thinking, the money is not mandatory, but the courage and confidence I can do that thing should be there. Then it is possible. We can make it happen.
Definitely, sir, definitely. Thank you so much. And this is another question. Um, yeah, they're asking about management tools. So, having navigated both the technical world of wind energy and the academic rigor of IIM, what is the one management tool you wish you had known earlier in the career that a chemistry student should start doing or practicing from the beginning?
See, management tool is, I say that, when you start your career, don't think on your numbers, how much you are earning it. So learning is important. Okay, learning the knowledge. That is what in my quote also I put, knowledge is the only wealth which no one can steal from you. So knowledge will pay you later on, more and more from this side, and some various pockets will get the income. The students should not focus at the initial days for earning. Like, if I join IT, I will get more. If I join this, so first you should gain knowledge. 1,000 days only your knowledge you go to. Knowledge will pay you a lot, according to me, and my experience is happening in me. Yeah, knowledge. First, after you completing your course, 1,000 days you should join somewhere, gain your knowledge.
You have to develop the skill first.
Knowledge plays a vital role. Yes.
That's great. That's great. Okay, here is the next question, sir. So, as we develop larger and more efficient wind turbines, what role does material chemistry plays in creating the advanced composites materials? So the blades, those materials, right, sir? Those polymer materials, those how it can withstand the environmental conditions while remaining lightweight and more efficient.
Yeah, see, we cannot avoid blades. Without blades, there is no wind turbines, right? So we need to upgrade how we are now. The technology has emerged from 200 kilowatt to now 4 megawatt. That is 20 turbines together, single. So day by day we are growing technological also. So it's a very good question. I mean, who has asked this question? Definitely he has watched my presentation thoroughly, so that this
Yes.
question has come up. The blades is playing a vital role in wind turbine technology. Okay, and the cost of per megawatt, I can say 8 crore rupees. So 4 megawatt is the almost 30 crores of the 4 8 so 32. So 30 crores per wind turbine is the prevailing models are going on. Out of this 32 crores, I can say almost 20%, that is 6 crores worth is the blade value. Okay, so in that a lot of chemical adhesives and all those things are being used, but I don't know that much technical the chemical materials, but polymer and fibers are used more. So the advancement in every area we need to upgrade it. Advancement is needed in every area. So this is a very good question, and yes, that gentleman or this he or she can focus on to join the blade manufacturer's factory, and they can add value in the production phase. And if they need the job in blade manufacturing plant, I can get them the job also.
Wow, that's great. So that question is
Yeah.
especially from our third year, Mr. Harini.
Wow.
Yes.
Very good. No, really, as a very good question. Yes, and she has focused on blade. In blade, yeah, a lot of chemicals we are using it for the manufacture. I don't know the name of the chemicals, but many of the chemical I can share that chemicals name. Maybe that may be useful for the students to understand what are the chemicals we are using it, because there are many layers. It is not a single piece of fiber. Many layers we are making it in the blades. So for that, the complete various chemicals we are using it. So I will share the detail. Yeah, it's an interesting
Sure.
question, ma'am. Yeah.
Thank you, sir. And this is the last question from our one more student. So it is actually about the green hydrogen you have mentioned. So, given your experience in carbon advisory and project management, what are the current industrial challenges in storing and transporting green hydrogen? Because we know that hydrogen is very combustible gas. So, how it is possible to store it and transport it? That's the question.
See, this battery energy storage and green hydrogen, why it came to India? One is the advancement, and secondly, there is a lack of evacuation infrastructure in our country. Evacuation infrastructure in the sense the generated electricity cannot be evacuated. The transmission, networks are very poor. It is not upgraded. It needs a lot of upgradation. Why the government is not able to do? Because for the upgradation, with good conductors and other things, they need to shut down the electricity, which is impossible at this moment. So for that, what they are doing, instead of upgrading the transmission network and other things, so they want to store it. Store it means whatever the surplus energy being generated by wind and solar, that is first initially stored at battery. As and when there is no wind and solar available, from the stored energy we are distributing the electricity from the battery to the industrial and domestic purpose. That means the green energy is stored, because the stored energy is also green energy. It is generated by wind and solar. The green energy only stored, and with that green energy we are using we are producing the green hydrogen, which we are using it for galvanizing plant and other things. So for the manufacturing plant, I can say all these four components. Wind and solar generation, surplus energy stored in the base battery energy storage system. From the battery energy storage system, again the green hydrogen. From the green hydrogen, whatever electricity generated through green hydrogen by using the renewable energy. Why we are calling it a green hydrogen? Because it is using wind and solar power for generating the electricity for the hydrogen. That we are using it for the manufacturing setup, like galvanizing plant and other things. So her question is what? This is the sequence happening. Can you please
The
repeat?
question is like, is it? So the question is like, what are the current industrial challenges, like storing and transporting the green hydrogen? Yeah,
Okay,
that's the
okay.
exact question.
Yeah. Challenges, we don't have a right, this battery energy design is still pending actually. Integrating all these four is the challenge now. Integrating the all four energies, and for transmitting the energy, because the lack of evacuation infrastructure we have.
So thank you so much for answering, sir. I have one small question from my end. Sir, we have talked about these blades and all this kind of grids, how it works, the kinetic energy to mechanical energy to electrical energy, all this is wonderful idea. And from a sustainability perspective, like know about the emerging technologies, how we are planning to recycle these turbine blades? They are made up of basically chemical polymers, right?
Right. See, now
How we are
earlier
planning
there
for
was
that?
no
What do you think?
earlier there was no solution at all, but now there is a solutions available. First of all, we are doing recycling tower and other things. We are using it for again manufacturing all the steel items. Okay, and the generator inside whatever coppers are available, we are using it for making the copper. We can use the copper and making transformer and other things. Only blade we were not having the solution, only for the blades, because it is a totally fiber materials. Right now we are using it, we are breaking that blades like a powder, like a grinding machine. We are using it for the compaction of the roads instead of cement. We are using that now fiber material in the road actually for the compaction. So it has worked very well. And in other countries we are using blade as a parking shed. Like for two-wheeler and parking shed, we are using as a parking shed. That also we are using it. I mean, for the roads and parking shed at this moment, blades. For blade only we were not having the solution, but now for these two purposes we are using it for the recycle bin. Recycling.
That's a great idea.
Yeah.
So that's an awesome interaction with you. So thank you so much for answering all the questions from our students and from myself. And I would like to hand over the session for a vote of thanks from Ms. Ashwini, Assistant Professor, Department of Chemistry.
Yeah.
Good afternoon to everyone joined us on the international seminar. It is my honor to give the vote of thanks for the third day of this week long international seminar organized by the Department of Chemistry at Sri Chandraprabhu Jain College, Nijur. First of all, we sincerely thank our respected expert speaker, Dr. N. Karunamooorthy, founder WINDPLUS Group and Director Gateway Groups. Sir, thank you for sharing your valuable knowledge, big energy, and for giving us a wonderful trust to this seminar. Your session, big energy, basic and its important source of energy, kinetic energy, mechanical energy, electrical energy, helped our students and faculty for their constant support and encouragement. Our special thanks to our organizing convener and head of the department, Dr. G.P. Bhavani, for organizing this meaningful program and bringing expert knowledge to young minds. We also thank all our students and faculty members for attending and actively participating. We hope today's session inspired you and will help you throughout this week. We look forward to meeting you all tomorrow at 11 a.m. for the next session with Mr. Karnaraja KKF. Once again, thank you everyone. Have a pleasant afternoon. Thank you, sir.
Thank you so much,
Thank
ma'am.
you, sir.
Thank you all.
Thank you very much, sir.
Thanks for the
Thank you, sir.
opportunity
Thank
of
you very much.
saving you. Thank you, ma'am. Thank you.
Thank you, sir.